Hello everyone, welcome to this session on Introduction to Bus Architecture. So before discussing on bus architecture, let's discuss on what is bus. So at a high level, we can say bus is a set of signal lines. Okay. But why they call bus? Because bus has two things. One is conductor and driver, like how the normal bus has. So conductor is a wire and driver is used to amplify the signals. Why we need to amplify the signal? Since the signal is traveling in the wire, um, after reaching the destination, it may become a weak signal. Here may be the strong, but here it may become weak. To boost the signal, we need a amplifier or driver here. That's why the we have a driver here. That's why we call every bus as a conductor and driver. Now, there are different specification levels. We can think like the logical specification at the first level. This is where the computer science students will think, where the sequence, how the sequence of events needs to be happened. For example, first you need to generate the address signal, then you need to generate the control signal, then you need to strobe or write the data into the data bus. Then the other view of the specification is the electrical specification, where like if you say the one in the bus, let's say this is 1 or 0 like digital signal. If it is 1 means what voltage level, whether it is 3.5 volt or 5 volt, what is the range of voltage. For example, 1 may be like if the voltage level is from 3.5 volt to 5 volt, then I can think as a 1. Else if it is 0 volt to let's say 1.5 volt, then I will think this as a 0 voltage level. Okay. Then the next is the mechanical specification, where we specify the what is the length of the conductor wires or which material is used on for the wire, all these things. Coming to the next, so what are the different types of bus in terms of master and slave connection? So this is where I'm going to explain now. So first configuration we'll discuss like where the system has one master and one slave. And the second type we'll discuss where the system has one master and multiple slaves. This is what AHB light protocol. And the last we'll discuss where there is multiple masters and multiple slaves. Okay. First, let's discuss on one master, one slave condition. So it's easy to implement because it's just as the master and slave, and you have one write data bus and address bus, control bus, and you have a read data. So how the sequence will happen? Master will first write the address into the address bus and then generate the control signal. Let's say I want to do read or write. Let's say I want to do read, then assert the read signal, and then slave will respond to that. What it will do, it will write that data into the data bus. Now master needs to strobe that, right? Then if let's say master needs to read that write the data, then what it will do, the master will assert the write signal. And then what master needs to do, master needs to also write the data into the data bus. Now slave know that I need to read that. For slave it is read, right? So what slave will do, slave will strobe the data which is there in the data bus. So this is very easy to implement. Okay. Now the next level is where you have one master and multiple slaves. This is what at a high level you can say HB light protocol. How it will work? It has two main components. One is decoder and multiplexer. Okay, these two components helping to connect one master to multiple slaves. Okay, so this we already discussed, right? In the previous slide, you have data bus, two data bus. So this is a write data bus, and this is your read data. Okay, this is your control signal, and this is your address bus. What will happen is master will generate the address, and based on address, this decoder will select one slave. Let's say master generated address for slave 2. Then decoder will select this slave. Okay, this slave will be selected. Now let's say master wants to write the data, then what it will do, it will assert write signal here and then write the data into data bus. Now um, slave will take the data. Let's say if master wants to read, then what it will do, it will assert read signal here, then slave will return the data, so that will come here. Now since we have multiple slaves, all the data will be here. Now it's the responsibility of decoder that will select this line to here. Now you will get the data. So this is how it works. So you have multiple slaves. First thing is master generates the address that based on address. It also goes to slave because the address needs to be there, right? At which address you need to read or write. So that address also goes to slave, all the slaves. But out of all the slaves, which slave needs to be selected? That is based on this decoder. So decoder will select which slave needs to be selected, and output or the data of that slave is coming to this multiplexer, and this decoder again selects which line to be selected. Let's say this is line 0 or line 1, line 2. In our case, line 1 needs to be merged with this line. So this is how it high level it works. This is same as a HB Lite protocol. Okay, coming to these, where you have multiple masters and multiple slaves. So here only thing is you just, it's same as one master multiple slaves. Here only one problem comes with multiple master. Let's say you have master 1, okay, and you have master 2, okay, and both are trying to access, let's say slave 1, okay, slave 1, both are trying to access. Then there's a collision happens, right? So someone in the middle needs to allow or deny. Let's say this master 1 or both are trying to access together. Someone has to be having some more priority, so that one, for that master it has to grant, and other needs to be wait until this master 1 completes. This block is called arbiter. Okay, so other than that, logic wise everything same, only arbiter is included more. So how it is? So here multiple master case, you have multiple layer for each master. Each layer you can think of same as this one. So you have layer 1 where each layer has that goes to what, this decoder, right? You say same here. One thing is different is here they didn't mention, here I didn't mention the multiplexer. The output of slave also goes to the multiplexer to the master, that I didn't here mention. But at a high level you can say each layer is having what, the decoder, multiplexer, and arbiter. Let's see how it works. Let's say both, let's say master 1, both master 1 and master 2 wants to access slave 2. So both trying to access at the same time. What will happen, it will, this signal goes to this decoder, and signal means address goes to the decoder, and this master 2 also generate address that goes to decoder. Based on these, decoder knows which slave to select, so it will send the signal to this arbiter saying I need access to slave 2. Now at the same time, parallelly, this decoder also knows it has to goes to where, this slave 2. Now it is the responsibility of this arbiter to choose which master to grant which master to the slave access. Now this can be, so let's say this can be like priority. For example, this master 1 always has to be having highest priority. If I configure the arbiter something like that, then what it will do, it will grant master 1, and for master 2 it will say wait. Now what it will do, master 2 will go and access. Access means it got grant. So what it will do, it will assert other signals like control signal and data signal and all, and then operation will be succeed. Once this operation is succeed, now master 2 may retry. Master 2 will retry that, that I need again access to, I need access to slave 2. So what it will do, it will again go and request. Since this time only this master 2 is going to arbiter, now our arbiter will do, arbiter will grant the access to the bus. So what then master 2 will do, master 2 will assert other control signals and data signals if required. If it is write, data signal. If it is read, it will strobe whatever the data coming out of this slave 2. But but this out of multiple slaves. So here also you have like multiple slave outputs. like this, and you have here one multiplexer. Okay, and this multiplexer is connected to this decoder. So this decoder is connected to this multiplexer, and which line is selected, that line, and then so which slave is selected, that based on that, that line goes to the master. Okay, so this is also, it's like high level, like you have multiple master, you have interconnect matrix. What interconnect matrix has, it has three components. One is decoder, which is used to decode the incoming address and select the particular slave. And multiplexer, why we need multiplexer? Multiplexer will take the output of all the slaves, and this decoder will select the particular line out of multiple slaves. Means it just configures the multiplexer, and output of the multiplexer goes to, oh sorry, not this multiplexer, this goes to here. Okay, yeah. uh, what is the use of this multiplexer? It is just like, it is the signal is coming here, and it just routes to which orbiter to go. For example, if slave 1, then it routes here. If it is slave 2, it routes here. So that's the use of this multiplexer. Yeah, thanks for watching my video.